These are the notes for 3.4. In 3.4, you talked about relationships when two functions are equal or when two functions are related by an inequality. So not equal, but there's a relationship between them. The first example is related to both of those, which is that you're given a function, f of x equals 18 minus 2x, and you're asked to find x when f of x equals 10. So you're used to being given a value for x and plugging that in. In this case, you're given a value for f of x. So in my equation, I need to replace f of x with 10. That's what this says. This says, I know what f of x is. It's 10. So now I can solve this problem. Subtract 18 on both sides. Divide both sides by -2. So we can say x equals 4 when f of x equals 10. Now, this is the part where we're really looking at that title for our notes. In here, we're looking at a graph, and we're looking at two examples. For using that graph. The first example asks us to find f of x equals g of x. So this is asking for where is it on this graph that the two y's are equal? So I need it to happen somewhere on this graph where my y's are the same value when my x's are the same. So the easiest way to sort of see this is to take our pen or pencil and slide it across our coordinate plane here. Now, right here, I have a particular x value, but we can see that the y values are not the same. Same thing over here. I have a particular x value, x is 1, but my y values are not the same. So maybe we'll even label those points. Maybe we'll say this point is -2, 2. This one is -2, -3. This one is 1, 3. And this one is, this one's going to be not quite exact. So this one down here is going to be 1, approximately -6.6, somewhere around there. So I can see that in both of these instances, the y's are not the same. The x's are, but the y's are not. So the one place where the x's and the y's are the same in both functions, and I should have labeled both of these functions. So this is f of x and this is g of x, is right here. At this point, -1, -1, both functions have -1 as the point. Right here, this is on the g of x function, this is on the f of x function. So when we find f of x equals g of x, we say that that happens at -1, -1. Now the second question that they commonly ask to go with this type of graph is on what interval is f of x greater than g of x? So luckily, I've labeled a bunch of things already on this graph. So let's look at them. We know that right here, the y's are the same. Both of them are -1. -1, -1 for g of x, and -1, -1 for f of x. So this y value is the same. However, if I look at some of the other points that I labeled, I can see that these y values are not the same, and the g of x function is a bigger number than the f of x function. And these y values are not the same, But over here, the f of x function is bigger than the g of x function. So something happens when I cross this point. To the left of this point, g of x is larger. To the right of this point, f of x is larger. So I need to go back and read which part they want, and they want when the f of x is larger. So that happens starting here and continuing on forever. Now we have to be very careful about, let's just note, this is the x values, but let's note that actually it's down here that it starts. So I need to look at the x values. In this case, because it was greater than, it doesn't include this point, so it's like an open circle. And so now I look at those x values and I say, well, I have x values that are greater than, starting at -1 and getting bigger. So my interval in which I have f of x greater than g of x is greater than -1. You could also write that answer as from -1 to infinity.